So for the last section of Psych 521, we're going to be focusing on techniques that are, again, advancements on multiple regression. So we just spent a section talking about MANOVA and MANCOVA, and specifically, again, the way I kind of defined these was that they were multiple regressions that had been focused to look for a specific purpose. So again, multiple regression allows us to look at just about anything in any way. But because of that kitchen sink phenomenon and that we have to kind of trick it to look at categorical variables, if we're finding a particular type of analysis needs a categorical variable, either within the predictor set or in the outcome set, multiple regression can be made to do that, but it's not actually designed to do that. And therefore, a fair amount of statistical techniques have been kind of created building off of multiple regression to do a very specific function. And MANOVA is an example of that, where we have multiple predictors and multiple outcomes. However, those multiple predictors are categorical, something that would be much more difficult to do in multiple regression, and has multiple outcomes, which again is not normally possible with multiple regression, because though multiple regression is that kitchen sink technique, it still has that requirement of a single outcome. Though of course you could run multiple regressions, but then we get into alpha inflation. So for this last section of the class, we're going to be looking at specifically techniques that look at factors or clusters of predictors. So we're taking another step of the onion, if you will, and also refining the basic mathematics and concepts of multiple regression into looking at specific patterns of data within a larger data set. So the first one we're going to look at is a fairly simplistic, actually, form of it, and it's discriminant function analysis. So we're going to be talking about what is discriminant function analysis, when would you use it, and what are the analytic procedures. And again, what defines this differently than a lot of the other predictors that we've talked about or statistical techniques is that idea that what we're looking for is clusters of predictors or factors. So we're going to hear the word factor or function a lot in the next 2 or 3 lectures. So discriminant function analysis is used when the dependent variable is categorical. However, unlike logistic regression, it is not limited to dichotomous outcomes. It is not necessarily better than ordinal regression if the data is ordinal. So again, we have some techniques we've already talked about, multiple regression specifically designed to look for a dichotomous outcome. And we've also talked about multiple regression, though we didn't really get into it much, ordinal logistic regression, which looks at an ordinal outcome. So an outcome that has multiple categories, but those categories at least have order. So 1 is greater than 2, 2 is greater than 3, though it doesn't necessarily have equal interval. At that point, we'd have a continuous variable, and we wouldn't need to use these techniques at all. So discriminant function analysis is specifically designed for when we have a categorical DV, our outcome is categorical, and it has 3 or more levels. It can be used with one or many dependent variables. And really, it is basically used for one particular job. And that is, we're wanting to use a series of predictors to determine if we can predict group membership or diagnostic membership in a categorical outcome. So we can determine the relationship between the categories and the continuous independent variables for prediction and predicting classification into a categorical outcome. Now, because we have a categorical outcome, a categorical DV, this is where factors start to come involved. Because it may turn out that certain predictors are great at discriminating, for example, between group 1 and group 2, but do no good at all in predicting differences between group 1 and group 3. So we would want to cluster the variance. We'd want to make a factor of that variance with that particular predictor to where it's only doing one job and it's not using up power when we're trying to determine the difference between group 1 and group 3. So as we add more outcomes or more levels to that categorical DV, that outcome, as we have more groups that we're trying to categorize in, it's more and more likely we're not going to find a single cluster of independent variables or predictor variables that will unifiably define the differences between group 1, group 2, group 3, and group 4, for instance. Instead, we may find factors or clusters of variables that are good at predicting individual differences between certain groups. So in many ways, again, think of it this way. When we run a discriminant function analysis, we first want to ask, do we have a significant model? And then if we have a significant model, we now want to ask what significant factors allow us to make prediction and how good is that prediction? So again, we're talking about an omnibus test. Discriminant function analysis first is going to find out, can you predict anything with this set of predictors? And then once we know that, which predictors cluster or create factors which predict various differences in our outcome, that categorical variable, and then how good is that prediction? So for introduction to discriminant factor analysis, I'm going to use an example where we're trying to predict group membership in fandom. So can we predict if someone is a fan of Carrie Underwood, Elvis, and Marilyn Manson based on their enjoyment of reading, their enjoyment of dancing, and their enjoyment of watching TV? So we have three outcomes, or we have an outcome with three levels. We have a categorical outcome, Carrie Underwood, Elvis, or Marilyn Manson, and we have three continuous predictors. A rating of how much they enjoy reading, a rating of how much they enjoy dancing, and a rating of how much they enjoy watching TV. And the question is there a relationship between any of these predictors and that categorical outcome? If we find that there is a significant relation between those outcomes in general, the omnibus test, and the outcome, that categorical variable, then we want to look at the discriminant functions. So what factors or functions determine the difference between two or more groups by one or many of the predictors? So remember, not all predictors will discriminate between all groups. So example, differences in reading may be a great predictor between Underwood and Manson fans, but not between Manson and Elvis fans. So not only do we want to know, is there a significant relationship between the predictors and the outcome, we also want to ask, how are those functions or factors successfully predicting? How successful is that prediction? How much can we trust it? But also, are we able to truly distinguish between all the categories? So some of the outcomes we could find here is we could have a discriminant function analysis that is significant and is great at identifying whether you're a Carrie Underwood fan or a Marilyn Manson fan, but really is very weak at determining if you're an Elvis fan. It tends to basically suggest that you're either one or the other, Underwood or Manson. What we're really hoping for a good discriminant function analysis not only is that it's significant, the entire test, but also that those factors or functions do a great job at discriminating between all of the categories. So the next section we're going to move on to is actually running through the analytic process of running a discriminant function analysis, kind of what's happening on the theoretical level. So the questions addressed by discriminant function analysis: can group membership be related to a set of predictors, i.e., is there differences between the categorical groups? And can our predictors, our IVs, predict that DV? If so, what is the effect size? So how much variance is being predicted? How much can we trust that prediction? And how important are each predictor within the factor? So predictive discriminant function analysis moves further. So descriptive function descriptive discriminant function factor discriminant analysis. When we're talking about the first level, all we're doing is kind of asking, is there a relationship? What are the effect size? How important? So this would be a descriptive study. However, generally speaking, we're usually using these in more applied settings. We're not just wanting to do the descriptive, we're wanting to move on to the predictive. Now, getting to the predictive, you go through the descriptive steps anyway. So you want to ask, question one, can group membership be related? So is the model itself significant? You want to ask, what is the effect size? So how much variance is being explained? And you also want to look at how important are predictors. Are there certain factors that have a high effect size, but may have individual IVs that aren't really adding to that model? Moving on to the predictive part of this, we now want to ask, how can we classify units into groups? And units are people, so how could we use this to actually make prediction? How many dimensions distinguish the group? So how many factors do we need to be accurate in determining what group each person ends up in that categorical DV? What are those dimensions? So in other words, what predictors go into each factor or function? Can we predict classification? So how good is that prediction and how accurate is that classification?